Hey there, everyone. In today's teaching lesson, I'm going to show you how to use optimization to find the shortest distance between a bunch of addresses. We're going to use Google Maps for this exercise. It's going to be pretty cool. I think you're going to learn a ton. So we're going to use a few technologies. Google Maps, Folium Maps. I talked about this in a couple of my other videos. Google Maps is very cool. It has a lot of functionality, a lot of interactive controls that you can deploy, and it's going to make your life very easy if you have to do anything with distance matrices, Google Maps, Google Places, anything like that. It's very powerful, very scalable. They give you a bunch of API calls. I forgot offhand, I think it's like 100,000 in 24-hour period or something like that. It's pretty generous. They give you a lot of data for free. If you're using this on a massive scale, you would have to pay and sign up for an account. But even then, even if you're paying, it's pennies per like 10,000 API calls or something. You have to look at the documentation. I don't know all the details offhand, but they give you a lot for free. And if you do exceed that, you can sign up for a paid subscription, and it's very affordable, super, super affordable. So we're going to do a few things here. You have to go ahead and apply for Google Maps API key. So I'll put that in the notes here. And just go to the GCP webpage, go to the console, and look for Google Maps API. It's pretty intuitive. Click around a little bit, and you will see that, and you can apply for an API key. You need this to interact with their server, right? You can make a call or a call request and fetch the data based on the API address, but you have to set up your own. I can't display mine, and I can't run this in real time. Like most of these demos, I will refresh the Jupyter Notebook cell by hitting Control Enter. I can't do that because it's going to fail because I don't have my API here, but I just can't display that, right? That's confidential. You can't give that to anyone. When you have yours, you can't share it. I can't share mine. So I did this before hitting the record button, but I'll take you through all the code and show you how this works. And of course, I'm going to share the code with everybody at the end of the video. When I post the video later today, I'll share all this source code with you except for the API key. You have to get your own, but it's trivial. Takes about 30 seconds, maybe 60 if you don't know what you're doing, just to navigate through the GCP menus. But you can get your own very quickly, totally free, and it's pretty generous. They give you a liberal amount of data, and you can do a lot with that, okay? So the documentation is on Google Maps too, so that's how I found out about a lot of these things. You would go ahead and set up a distance matrix so you can figure out the distance between the origin and the destination. The origin is the starting point, destination is where you finish, right? And you would have to set up a distance matrix. I do this a couple times in a couple other videos too, so you'll get a better sense of how to do that. Once you have the distance matrix, it'll show you all the distances between all the points that you're going to. It's like every possible combination of the distance between every address, and that's how Google Maps knows how to route you to the shortest route. So I'm sure you've used this when you're driving in your car, whether you're the driver or the passenger. You use Google Maps to find out where you're going to, right? They calculate a matrix, and they'll refresh it constantly, so the matrix is constantly being rebuilt. And then you can find alternate routes if there's a lot of traffic on the road, or the traffic has been diverted because of an accident or something like that. Like the Google matrix will be recalculated, and then you will be guided to the next most efficient route, right? If the original one was closed due to some kind of unforeseen event, a new route will be plotted. And of course, when you're going somewhere, there's many ways to get to the same destination, right? There's probably dozens, maybe 100 different ways you can take, all back roads, highways, scenic routes. The absolute most efficient route, in this case, we're going to take the shortest distance, but there's many ways to get to the destination, right? So you calculate your distance matrix, and from that, you can calculate the optimized route, okay? And we're doing that too. We're looping through all of the orders of routes to get there, and this is a looping session right here, right? So you have 4i, that's the loop, and closest order. And the closest order is to find the distances between all of these distance matrices, right? So distances, you can see, is a sorry, trying to temporary blank here. Distance is a list, yeah, list, and you're appending all the items into the list based on the rows of those distances. Okay, so that's the first function, optimized route. You find the closest location, again, minimizing the distance between all those source addresses and destination addresses, right, and get the nearest neighbor. Okay, that is right there. And at the same time, you're seeing which addresses have not been visited yet, right? So you go into each address exactly once. If you've been to the address, you're not going back there, and you're looking for the shortest distance between all the addresses simultaneously. That's how this thing works, okay? So we'll find the total distance. We want to find the total distance just to see how far we're driving, and then the total time to get from the origin to the destination and make all the stopover points in between too, okay? And then we're going to plot everything on the map. So that's what this does. Took me a little while to figure out all the details here, but don't worry about it. All the hard work is done. I'm going to share the code with you. You can copy and paste it into your own Jupyter Notebook environment and run it, and I think you're going to be pretty amazed by what it can do. So here's the addresses. I picked 5 kind of close to me. So we start here in Long Island City, 509 48th Avenue. That's right down the street from me. 102 Montague Street. So that's in Brooklyn. You go over the Pulaski Bridge. We're going to Wall Street, Center Boulevard. That's actually close to 509 48th. So this is not going in any specific order of efficiency or shortest distance. I just picked 5 addresses, 1, 2, 3, 5. And then I said to Google Maps, I want to go to all 5. I want you to plot the most efficient route on the map for me. So that's exactly what it does. And it's so efficient, it draws straight lines between these. So it goes to the 2 addresses that are close to each other here. Then it goes down to this, number 3. And I don't think in this map, yeah, this is not set, but with these markers, you can easily set up the address when you click on this blue pin right here. Oh, it is set up. It is, okay. So that's nice. So that's a tooltip or a pop-up. So it shows you the address here, right? And then this one down here. So that would be 1, 2, 3. This is number 4. And this looks like Montague Street. And then we go down here. This, I think, is Wall Street. That's the final stopping over point. 100 Wall Street. Okay, so now we're in downtown Manhattan, New York City. So that's great, but if you're paying attention here, even if you're not, you might say, this looks a little bit weird. Why is this straight line? That's like the crow flies, or if you were going from one place to another in a helicopter, that's highly unlikely. So this is the most efficient route, but realistically, you're not flying like a bird to get from one point to another, and you probably don't have your own private helicopter to take you around. So you're probably going to have to follow the paths of the streets, right? So that's why we need Google Maps. So we figured out the most efficient way to get from A to B to C to D to E. But realistically, we can't just go straight, right? We have to follow the contour of the road. So we need another call request to the Google Maps API. We have our API keys and all the addresses planned from above. Okay, so there's the key, there's the address, and we're telling it to calculate the total distance. I want to know how long we're driving for and the total time it takes. But we also have to find the closest location, and we have to adhere to the contours of the streets, right? All the one-ways, all the switchbacks. You have to take a slight right or a slight left, or maybe make a U-turn or something like that. Like we have to accommodate all the legitimate street addresses and still get to those destinations, and still get to the final destination and hit all the stopover points too. So you can see it does kind of become a little bit of a tedious task. This is not trivial by any means. It takes like a little bit of effort. But again, I'm going to give you all the code. All you have to do is plug in your own addresses, and of course use your own API key. I'll go up and show you the address. Whoops, I'm zooming in on the map. Sorry about that. Let me get on the side here. So again, just get your own API key, get your own addresses here. That's all you're going to have to do. It's super easy, super simple. Plug in your own API, plug in your own addresses, and it can be a bunch. It doesn't have to be just 5. It doesn't have to be just a handful. It can be lots and lots. On Google Maps, I think they'll let you see 10, but this is like a different way of interfacing with Google Maps. So this is, I don't know what the limit is. I don't think it's unlimited, but I'm sure you can do more than 5. I just tested 5, but I'm guessing you can do dozens and dozens of these. So here I'm calculating the total meters traveled from point A to B to C to E to E. So the first one, those first two are very close to each other, so 339 meters. The next one goes from Queens to Brooklyn, so that it's 3,960 meters. This is cumulative, okay? So it's summing up everything from the prior step. Now 11, 145, then 15,000 meters is over 15,000. So we have the distance traveled, and again, we're conforming to the guidelines of the streets, right? We can't cross over the streets. We have to follow one-way street signs if there's sanctions like that or whatever the thing is. Like Google Maps will handle that for you. All you need to do is put in your address and your API key, and it's going to deliver some pretty spectacular results. So that's it. That's how you get from A to B to C to E, and so on and so forth. If you have many distances, Google Maps will accommodate all those. And again, find the shortest distance so you can hit all your stopover points. I'm sure Amazon does this with all their delivery trucks, or something to this degree. They've got to be doing that to make it efficient, because that business is so massive. They can't just be driving around all day aimlessly. They have to have some kind of system in place that helps them to drive the minimal distance and meet all the criteria of dropping off every package that needs to be delivered to. Okay, so that's pretty much it, guys. We've reached the end. Hopefully you stuck with me until the very end here. And yeah, hopefully you learned something new. I'm going to share all this code. I'm going to post online when I post the video. Thank you so much for your time today. Have a great rest of your day.